So I'm going to talk a bit about my journey to find different type of macOS vulnerabilities, and especially this time about the one specific one which is related to the Apple calendar. There was if you read the description originally, like 2 weeks ago, there was a little bit more also in that description, but unfortunately, I will more concentrating to the first part of that vulnerability chain. That is because not all of the things are, those are not yet fixed fully. So I will concentrate to the things which are actually fixed and talk about a little bit about the background related to that. So my name is Mikko Kenttälä. I'm one of the founders and CEO of SensorFu. I've been doing hacking since the high school, hacking and breaking different kind of stuff. In SensorFu we build cybersecurity products. That's a different story, but this is more about my happy hacking process. What I do when I have a little bit free time as a hobby. So I really like to hack different type of softwares and devices and so on, only if I have a time though. But I tend to concentrate to the things what I'm using myself for some of the, well, to my personal use. So as you can see, I'm using Mac, so it's kind of convenient that I do research also related to some of the things in the Mac OS. Previously, I've had a publicly disclosed and wrote a blog post about the other vulnerabilities. You can find those out. There's the zero-click vulnerability related to the Mac OS Mail, where you basically, as an attacker, you are able to send a specifically crafted email to the victim, and it will automatically trigger in a way that after that email, all the emails will be forwarded also to the attacker. So there was a way to manipulate the configuration of the victim's email client. And there's a blog post about that. I've been giving a couple of presentations about another one also that was related to that was like a full vulnerability chain related to the macOS. It all started from the point of view where the user decides to click download button for a certain file, and the zip file will be downloaded. It will be automatically extracted because that's what Mac OS and Safari do. It will be automatically extracted, and that includes specific kind of application which will include Mac OS alias file, which will then launch a Samba mount, and after that there's a little bit trickery to get that Samba mount to arbitrary mount point to actually cause a completely different. When you launch terminal, the terminal will start using the configuration of from that Samba mount, and that will lead to the command execution. And after that, there's also evasion for some of the security mechanisms, which are basically restricting the access to the sensitive data in your macOS system. So that was quite a long chain of different type of vulnerabilities chained together. You can find the presentation from YouTube, so just Google with my name, or I think with that you will find actually a couple of different presentations about that. So the original plan was to actually introduce this type of chain, but in this case we need to concentrate more on the first part of it. So I will give you an idea a little bit and about background, how I do the actual vulnerability research manually, and how I operate, so how these things are found, and then we move into the actual calendar application and how that exactly works and what exactly was the vulnerability. All right, so this is question what I have got quite often after my presentation, that how exactly and how easy it is to actually find those bugs. And For me, it's hard to say how easy it is because I have a background of doing technical security audits, like we did it together with my colleague. We did 5-day technical security audits, like 5 years, until 5 years ago or 6 years ago, so quite a long time. And during that time, there was a certain pattern what we were like repeating, and most of the time we found some vulnerabilities. So we've been following back then this type of methodology, which is rather straightforward, and I think it is nothing new for those who have been in the business for quite a long time. And this is, as you can see, there's nothing like a specific technology what I'm using or something like that. It's more like a fundamental idea. So the step one is to learn as much as possible from the system. So you might want to check out the documentation, do some reverse engineering. That is bolded in this case because I'm many times concentrating to that. And when I find something interesting, I read more the documentation side. And basically the ultimate goal is to actually know exactly what is happening behind the scenes when you are using some application or when you are using some service at the internet. Then the goal is to try to find out some sort of anomaly. So then you have a base understanding that, okay, this is how it should work. So when I'm doing this, this is the path what should happen after that when I do this thing. For if you send an email, you accept that the receiver will get the email or something like that, and then check it from the technical point of view and try to find if you can cause some anomaly related to the process what is going on over there. So can you manipulate the sum of the processes or the application or the services what you are actually using? That is the goal. If you have some room over there, try to find out, can you change somehow the environment in a way that it will cause some surprising things related to that application. These are a little bit abstract, but that is because in different cases, this might mean different things. So you may have in practice, this may vary a lot what it means in practice, but this is basically the goal in that second step. Then if you find out some error or some malfunction of the software when you are putting some of your own input to the software, and this software will crash or do something which is a little bit surprising, try to look the ways to get more privileges with the existing function. So if you are using some specific thing, think about it that, okay, this is designed for this usage, most likely, or that to try to figure that out. And then later on, try to figure out that can you do actually something else? What may be something what the original designer or coder has not been thinking of. And that is exactly the place where you most likely can do the exploitation later on. Many times nowadays, because we have in cybersecurity software side, we have quite a good mitigations in place, or plenty of those mitigations. It might mean that you cannot directly cause some exploitation to that specific vulnerability. It may be that you just have some really tiny capability and you need to figure out how maybe some other software you can cause some troubles to some completely different software or completely different function in that field. And in macOS case, there's also these mitigations are basically, there's 3 or 4 different type of common mitigations what you need to worry about if you want to get access to all the data in the system or the sensitive data in the system. So obviously, you need to exploit the initial vulnerability in the software, but then you are most likely in sandbox. If you want to run some third-party application or bring in new code, you need to somehow fool the gatekeeper. Gatekeeper is a software which is designed for doing exactly that, that if you have some code which is coming from outside, you need to specifically allow to that software to be run. So if you want to exploit without the user interaction, you need to figure out how to evade that. Then if you want to access to some of the sensitive data, you need to get rid of the controls related to the TCC, which is basically protecting all the data files in at your desktop, photos, location, web camera access, so on. So that is the exact piece of technology which is trying to put good controls for the user for all the sensitive data. So that's another obstacle. And many times is to actually fool these other security measures, you may need to evade the system integrity protection, which is basically protecting all the different parts of the actual operating system, including those TCC and gatekeeper. So you cannot even if you have permissions from the Unix point of view that you are, as a user, you should be able to manipulate some of the files in the file system, SIP may be protecting those files. So these kind of things. I have, you can check out the YouTube video about my previous presentation. I go more deeply into this topic, and there's also examples how I have done it before. So today we are not going to go fully into that. But today we are going to talk about the zero-click invite. How many of you need to use some sort of calendar as a daily basis when you are doing business or working or in the family? Yeah, most of you. There's a story why I dived into this topic, and that was that, like I said before, I've done technical security audits for customers for already 10 years ago or so. And around 10 years ago, one of the objectives was to check out one specific calendar system for the customer or a client. And I did a deep dive to the calendar system 10 years ago. And we found some vulnerabilities. And back then, I decided that I'm not going to use calendar too much in the future because it's so troublesome in many ways. The specification allows things like causing an you can send an event which includes an alert which can point to the specific application which will launch on that event of alert and so on. So most of these have been fixed over the years in the clients. However, the idea how it fundamentally works was a little bit troubling for me, and so I basically started to use just like a web calendar, web application calendar, like a Google Calendar or so on. However, all of this changed when we founded the company, and we basically figured out that if you want to have a meeting with the customer, you need to use the calendar and you need to use the calendar invitation, because otherwise, 70% of the time you are sitting alone in your meeting room waiting that the customer will join in, but they don't because they didn't receive the calendar invitation. So I started to use more of this, but that was troubling in the sense that I needed to also go and check that how well the calendar actually work. So this has been on my to-do list for quite a long time. However, I haven't had too much time to actually dive in. So I did it quite recently. So Apple Calendar is like many other calendar applications, really straightforward in the sense you can imagine what you can do with it. It supports iCloud, Google Calendar, Exchange, and external CalDAV servers. So it's quite handy and works well with that. There's some specific things related to the Apple Calendar that if you are using the iCloud, for example, with the Apple Calendar, you can basically do invitations for your other friends who are using also the iCloud, and it will be fluent because there's no email required and so on. So it's quite handy in that sense. Sometimes if you're an Apple user or Mac user, you will find out that when you receive an email which includes some event, calendar event, that may be automatically added to your calendar. And actually Siri does it too. So when you receive an airplane ticket or something like that, Siri will figure out that, okay, you will have a flight, so let's add that to your calendar. And it is super handy. I actually love that function. However, from the security point of view, that ringed some bells to me that this is also a little bit troubling that if I just receive an email, I have some events popping to my calendar, so it may be risky. The format what is used is iCalendar format. It's rather old, but there's nothing wrong to being old. So in that sense, so it's really straightforward protocol. So it looks like this. If you open some of your invitations, you will see something like that. That kind of data in the calendar event. It is originally introduced in '98, and it is basically plain text file format. So that is also good for testing purposes because it's not hard to manipulate that type of data and play around with it. So, but later on, there was a support for syncing the calendars, and there was CalDAV was introduced. Based on Wikipedia, it was introduced in 2007, so much later. However, the technology behind it is based on WebDAV, which has been introduced in '96. The fundamental idea is rather straightforward. CalDAV server is HTTP-based service, which basically receives and provides those ICS files to the email clients. There is some part of, there's specific things in the protocol for notifying the user that, okay, there's a new event coming and so on. But basically, that CalDAV is like, it's syncing those ICS files to the server and from the server to all the clients. Rather straightforward. And once again, it's good for testing purposes also. One nitty or not that good thing is that if you want to host your own calendar server, there's no good options anymore available. All of the things seems to be mostly legacy stuff, and I'm guessing that same thing might apply to the Apple's iCloud side and any other provider who is out there. So most likely there will be some Java and something like that behind the scenes. I'm not sure, but I'm just guessing. But then there's an invitation, which is the exact thing which is so important when you're in daily basis of doing business. How that invitation actually works. So it's once again rather straightforward. You can even manually add attendee to the ICS file and put the contact name over there, email address, and so on. And you just push that information to your CalDAV server, and the user will receive the invitation automatically, especially if he or she is using the same service. If you want to send it to someone who is outside, you maybe add this file to the email attachment or something like that, and that way they will get the invitation. But once again, from the protocol point of view, it is really straightforward. And then there's a feature related to the attachment. So this was I was playing around with the calendar, figuring out that what I can do with it, what are all the functions which are available over there. And one of the things from the attacker point of view, which was interesting to me, was the attachment. Attachment, once again, works it's really simple how it works. You just add the file name, then you add specific entries, and you may add the URL to over there, which in Apple Calendar case, if it's up, it will be automatically uploaded to the iCloud and can be automatically downloaded from there. So quite straightforward. Old way of doing things is also that you can add the attachments directly as a base64 encoded data. So if you have small files like TXTs or something like that, it may be handy handy way to actually share the attachment. And it will be part of the calendar event, what also the invitees will actually receive. So that's something what was worrying me. And every time when you get that kind of event, the calendar, and this is Mac OS, not on iPhone, calendar application will store that attachment to the calendar library, calendars, then you have a calendar ID, and then you have attachments over there, and then there's event ID, and the file is stored over there. So it's in your file system. Once again, you don't need to do anything. It will just appear magically over there. So if I want to invite user, I want to some file to be on the system what they are using, I can add an attachment and send it to everyone or whoever I want. Especially if they are using iCloud, it will be just automatically pop up to the calendar, including that file. That file will be downloaded or extracted to this specific place in the file system. So, do you think that this may be risky? It can be, yes. So, I started to play around, obviously, with this because this is a great way to get files to victims' system, and there was an arbitrary file write vulnerability. How many of you can guess that what might be the way to get arbitrary file write with that technology? Yeah, that's a good answer, and I think just doing this. So you just set the file name. So this was it. So I don't know. This was related to the attachment. I think this is on the playbooks of red teamers on the page 1 to test these kind of things. So what will happen if I instead of putting a specific file name, I put a relative name for the file. So it's pointing like .. and POC. It means that it will be stored to some completely different directory than what it should be stored. So over 10 years ago, when we did those technical security audits, this kind of things was exactly what we were founding of. So, but it's not. I think I've been thinking of this because I've found multiple this type of cases. Also in Mac OS, but also in other systems, that I feel that it may be that all of us who were doing technical security audits 10 years ago is now doing something else because this has been over there quite a long time. And it's rather simple to find out if you know what to test, but it's been over there quite a long time. And yeah. But then there's also arbitrary file delete. And this is kind of logic error in the calendar application. So if I set the name like a calendar cache is one of the files which is existing in the library calendar folder. So if I put the name, file name to that, it won't overwrite the existing file. Instead, it will add an additional file with -1. Or -2 if there's already that, and so on. It will iterate. However, if I, as an attacker, if I delete the attachment afterwards, and the client will receive the update that, okay, this file is now removed, it will remove the original file in the file system. So you can basically put any file in the file system in that sandbox though, and it will be removed. So this specific case will cause the Apple Calendar to crash because it's using that cache all the time, and all of a sudden it's not in use anymore, so it will eventually crash, and it will take a couple of times to actually try to restart the application to make it trigger some kind of fail-safe, and it will kind of rebuild the cache again and it restores. So this was one of the things what I also wrote to the report. There was some limitations. So calendar application is running the sandbox. So because of that, and that is really good thing, you are able to only write to these specific directories. So calendar, then there's a container system related to the calendar agent, which is running on the background. That folder you can write or delete files. Then address book. I guess the address book is used because when you're inviting someone to your event, you will have the list of or if you try to invite, and you will get the contacts from your address book, so it's needed, and there's maybe for that reason that is allowed. Then there's the sync service, which is allowed to write and read. However, I think that is actually deprecated service, so it shouldn't be over there, but I just found out looking the syscalls that what is checked when you launch the calendar application. That was one of the things what was checked, so I tried to write over there, and it worked. So what you can do as an attacker, you can infect the victim with sending a calendar invitation. It will nicely pop up on victim's calendar automatically. It will include the payload. It will be written to the file system, and something else might happen that afterwards. I did that something else also, but that is maybe more for the future. So after the summer, I found the original vulnerability. I sent the report to the Apple. It was fixed fairly quickly, so 2 months or so, a bit over. There was no CVE for that. I'm not sure why. It was when Ventura 13 was, actually macOS 13 was introduced, it was already fixed over there. I was actually in the middle of, I found the vulnerability, I was still on the Ventura beta 3, so I was like, okay, it looks like it is working. And then I was writing the report and found out, oh, there's a new beta version available. I updated to the beta 4, and it was fixed in beta 4. So I was surprised that, all right, maybe someone else found it, or maybe they are doing changes to the new calendar, and maybe that fixed it. It might be it because there was design changes in Ventura that how calendar work. It's moving more to the direction of how your iPhone calendar is working, and that is good. It is much, permissions are distinct more carefully and so on. So it is going to the better direction anyway. Then again, I later on followed up with the proof of concept that how to leverage the vulnerability to get arbitrary code execution, and a little bit later of that, I followed up that how you can get actually sensitive data actually out of it with leveraging that vulnerability. However, the story will continue later on. I was hoping to get this to introduced for you over here, but we need to wait out that all the things are completely fixed and everything is in good shape before disclosing these. So in next episode, you will hear that how you can leverage that vulnerability to get the code execution from the escape from the sandbox and gaining the access to the sensitive data. All right, thank you. And if you have any comments or questions, feel free to ask. Thank you. Yeah, that's a good point. Nextcloud is one of the systems which is providing. Do you know, is it like a fully written again, or are they using some existing old technology?
Not entirely sure, but
yeah.
At least they haven't had that much major vulnerabilities in recent history. So
Yeah. Yeah, so and that might be something what you want to try out, because all of the calendar systems and those are full of these kind of features. I haven't tested any other because I'm not using any others. I'm using mainly Apple products for daily basis. So that's why I've tested that. So if you're Exchange user, go ahead and test it, or if you're using some other system, I recommend to try out. I know that 10 years ago there has been more vulnerabilities like this in those, also in server side, so that might be something to check out. Any other questions or comments? All right, looks good. Thank you everyone and see you next time.